Perhaps the most challenging and important concept for today's lessons is the difference between the nominal and effective interest rate. For this class, we use R for nominal interest rate and I for effective interest rate. So what is the difference between these two? Because it's important when we apply the equation, we have to work with the effective interest rate. But sometimes the problem gives you the nominal interest rate, how we convert. And when the problem gives that, can we know that is the nominal or effective? So let me give you some hint for this nominal and effective. When we consider a nominal interest rate, so we consider nominal interest rate R when the interest rate, when an interest rate is expressed over a period of time that different from the compound period. Okay, so that is nominal. Consider it's a nominal when interest is spread over a period of time it different from the compounding period. Different from compounding period. For example, if we have the effective interest rate is 1.5% per month. Compounded daily, or compounded monthly. And as you can see here, why I call this 1.5% is I, effective, not R. Because the interest is spread over month per month and the compounded monthly. What does that mean? They are the same. Then that will be I. If it's not the same, then it will be nominal interest. At the definition there, over a period of time different from the compounding period. So with that 1.5% effective interest, I can say that this one per month could be expressed as a nominal 4.5% per quarter. Per quarter it means 3 months. Just 1.5 times 3 is mean 4.5% per quarter. But then you see the interest is spread per quarter. Why the compound is monthly for this interest rate? So the quarter different from monthly because 1 quarter is 3 months, they are not the same. That's why it will be the nominal interest, 4.5% per quarter. Or it can be spread 9% per half year or semi-annually. Per semi-annual period. Or it can be a nominal at or 18% per year. And all of this number all is the nominal interest rate, not effective. 1.5% per month compounded monthly, that is effective interest rate height. We can say that is a nominal interest rate, 4.5% per quarter, 9% per semi-annual period, or 18% per year by we time the number of the compounding period. But the spread of this interest over a time different from the compounding period, then we don't consider that effective. It's nominal. So when it's nominal, we need to know how to convert to the effective, and that is the equation, and it also available on the reference, the FE exam reference, and that I use that for the exam 2 reference for this class. And we talk, if you see, go back to the first video of introduction, how we use the reference for this portion of class. So with that, how, when we know effective, how can we determine the effective interest rate? And that equation, like I say, available on the reference, and that I that we want to determine is equal to 1 plus R over M power M minus 1. So that the equation, that box that one, effective interest rate, and that available in the reference. And from that, what is M? M basically a number of compounding period. For example, here, the compounding per quarter, if I% is 1.5% per month, compounded monthly. So the number of compounding period is 3 months. Semi-annually period, if it compounded monthly, and the nominal is 9% per semi-annual period, is 6 months for will be for the compounding period. So that is the number of compounding period. For I and M, you already know that it's effective and nominal, but one note is very important. One note here very important, that is I and M and R, I and R have to be spread over a period of time. The same period of time have to be expressed over the same period of time. So that be aware. So when we find out the I per year, then the nominal that we apply in that equation, it have to be per year. If we want I per quarter, then the nominal interest rate have to be per quarter. So if it continuous interest rate, how about it compounded continuously? If the last one with that equation, compounded continuously. This means that not every second, but very small part of million of time. So we call it continuously. So with that, how can we find out with this one? So the number of compounding periods is go to infinity for any interest rate. So with that, the I, if it compounded in continuously, then the M, you can see infinity, and infinity we can plug in your calculator to do. Then we can have the limit, the I equal to the limit of 1 plus R over M minus 1, and M go to infinity and beyond for this equation, for this limit. And as you already know, a series with M go to infinity, 1 plus 1 over N power N, it will be E R, right? E. Then with that, your calculus with the limit, the traditional classics equation with the limit here, review your calculus. We have I, it will be equal to, if it compounded continuously, I equal to E power R minus 1. If compounded continuously. So we cannot plug M infinity in the calculator or in that equation. So that different scenarios, we need to know what is the difference between the nominal and effective. When the problem give you what is the nominal and what is the effective, and then apply the equation properly. Be careful, I and I in that equation, it have to be expressed over the same period of time. In the next video, I give you a few scenarios of when we consider that number is effective or nominal interest rate, and then we apply to the problem 4.